this map of the Indian Ocean. It covers a massive expanse of the Earth's surface, stretching from the eastern coast of Africa to the western shores of Australia, wrapping around the entire Indian subcontinent. For thousands of years, this enormous body of water, along with the Arabian Sea and the Bay of Bengal, has maintained a delicate thermal balance, providing a stable, life-giving resource for hundreds of millions of people who live along these coastlines. But according to the Indian National Center for Ocean Information Services, that equilibrium is breaking down. Monitoring systems have detected marine heat waves, prolonged periods of intense, ecologically unsustainable temperatures that are swallowing up entire regions of the sea. When a heat wave strikes on land, the effects are obvious. Crops wither and forests burn. But in the ocean, the crisis is largely invisible. The surface might look perfectly normal, but right underneath, immense bands of trapped heat are pushing deep into the water column, accumulating without any way to escape. From the beach, everything appears calm. Down in the dark, however, that trapped thermal energy is triggering chaos and a structural collapse hidden from view. The Indian Ocean has absorbed so much excess heat that it has crossed a critical threshold. A system that evolved to support marine life is steadily becoming a suffocating trap. Normally, deep, cold water cycles upward, carrying nutrients. But extreme warming creates a thick, hot surface layer, blocking this rising flow. Immediately, microscopic phytoplankton at the surface starve and die. Simultaneously, warmer water holds less dissolved oxygen, causing oxygenation to drop drastically. Marine ecosystems are caught between two distinct lethal forces. Lack of nutrients means they starve from the bottom of the food chain up, and deoxygenation means they suffocate in the water around them. The death of invisible algae and the quiet loss of dissolved gas might sound minor on their own, but this biological collapse at the microscopic level strictly dictates the survival of everything else in the sea, setting off a sequence of failures that eventually reaches the largest species. When the base of the food web collapses, the entire system fractures. The organisms hit hardest are the ones physically anchored in place. Corals survive through a delicate relationship with tiny algae living inside their tissues. When extreme temperatures hit, they undergo severe stress and expel these algae. This process is called coral bleaching. Without them, the corals slowly starve. When a reef dies, the damage extends all the way to the shore. These dense reef structures act as natural armor for the vulnerable coastline, physically breaking the aggressive force of incoming waves. Without them, coastal communities face severe land erosion, and a vital hub for marine biodiversity disappears. Corals cannot move, but fish are highly sensitive, feeling tiny temperature shifts and swimming away from heat. Look at this tracking map. It shows dense populations of commonly caught fish entirely abandoning their traditional shallow coastal breeding zones. To avoid the warm, low-oxygen water, entire species are migrating en masse, swarming toward deeper, cooler waters miles away from shore. This heat-driven biological migration is physically redrawing the map of the ocean. Coastal havens that teemed with life for thousands of years are rapidly emptying out into barren underwater deserts. The fish might survive the heat wave by fleeing, but millions of people living along the coastlines cannot follow them. For these communities, the ocean is their primary source of food and income. Because the fish have moved, traditional seasonal patterns and established fishing zones are broken. Fishermen are dropping their nets into areas that used to guarantee a massive catch, only to pull them up completely empty. Chasing the fish means leaving the safety of the shore. Fishers are forced to travel unprecedented distances into deep-sea territory to find the migrating schools. This creates an immediate economic crisis. Navigating deep, rough waters burns massive amounts of expensive fuel. It pushes crews to extreme physical exhaustion and places small boats in dangerous, life-threatening environments. The microscopic lack of nutrients has translated into macroeconomic ruin, breaking a centuries-old way of life for coastal communities in real time. The collapse unfolding in the Arabian Sea and the Bay of Bengal represents the Indian Ocean's role as a massive planetary buffer, trapping the world's excess thermal energy. Organizations are trying to adapt, They monitor the water and send out early warnings about marine heat stress so coastal towns can prepare. But observation alone cannot fix the underlying physics of a broken thermal equilibrium. The heat being trapped beneath the waves is the direct result of atmospheric warming. As greenhouse gases trap solar energy in the atmosphere, the Indian Ocean acts as a giant sponge, absorbing over 90% of that excess heat. If these warming trends continue, the ecological damage we're seeing, dead reefs and migrating fish, will result in irreversible, long-term structural damage that impacts generations. The Indian Ocean provides the first full-scale look at the cost of a warming planet, proof that regional devastation is the first stage of a global shift in how our oceans function. Unless global climate action radically cuts emissions, this level of ecological failure will become the standard operating condition.